Hi. So for this lesson, we'll be talking about describing motion with graphs, specifically using position versus time graph. Now, graphs in kinematics are very useful because we can use them to describe the motion of an object. So in a PT graph, we have the x-axis as your time and your y-axis as the position. So let's take a look at this one. We have here a car that is moving at a constant velocity. If we look at the illustration here of the movement of the car, we can say that it has a constant velocity because at every time interval, have here 1 second, and then another second, you have the same rate of change in position. In each second, the change in position is 10 meters, as you can see. Now, if we take all of that as points in our graph, remember again that in your position versus time graph, your x is your time while your y is your position. So taking this one, you have 0 second in x and 0 meters in y. So this is your point. Then the next one here, you have 1 second and 10 meters, 2 seconds and 20 meters, 3 seconds and 30 meters, 4 seconds and 40 meters, and 5 seconds, 50 meters, as you can see here in the illustration of the moving car. What we do now to create the graph is just to link all of these points. We link that. Oops, not that straight, but let's imagine it's straight. Let's do it again. Anyway, that's the graph of the moving car, which has a constant velocity. Now, graphs have this concept known as slope, and I hope you remember your lessons in math about slope, but let's take a quick review. The slope of the graph describes how steep your graph is, the rate of change in your y, and the rate of change in the x. Using slope equation, it says that the slope of a line is found by determining the amount of rise of the line, which is your change in y, between any 2 points divided by the amount of run, or the change in x, in the same point. So the slope of an equation is equal to the change in y, the rise, and the change in x. Now your change in y is equal to the difference between your 2 points in y that you are comparing, and your change in x is same, the difference between the 2 points in x that you are comparing. So if we solve for the slope of the graph that we have right now, you just need to take 2 points. So we have here, on the first example that we have here, we have 0 seconds and 0 meters, and we have this point, 5 seconds and 50 meters. So we label this as your point 1, and this is your point 2. And remember, the points in the graph have their x and y coordinates. So this one, you have 0 seconds, 0 second, and 0 meters. So this is your x1 and y1. For this one, for this point, you have 5 seconds as your x and 50 meters as your y. So this becomes your x2 and y2. Remember that the formula for slope is your rise over run, or your y2 minus y1 over x2 minus x1. And what's your y2 equal to? That's 50 meters, 0 meters for y1. And then 5 seconds for x2 and 0 seconds for 0 second for x1. 50 meters minus 0 meters will give us 50 meters. Then 5 seconds minus 0 second will give us 5 seconds. 50 meters divided by 5 seconds, then that is, of course, 50 divided by 5 is 10, with your units left meters per second. So the answer, or the slope of the graph, will be 50 or 10 meters per second. Now, if you take another point in this graph, you have here the same point, 5 seconds at 50 meters. However, the first point will be 2 seconds at 20 meters. So what you need to do is just the same. You need to identify your y2 and y1, and then your x2 and x1. You just need to substitute it. 50 meters minus 20 meters, and then 5 seconds minus 2 seconds. 50 minus 20, that's 30. 5 minus 2, that's 3. So 50 meters divided by 3 seconds, you'll get 10 meters per second. Again, if you take another point, you'll get 10 meters per second again. Why is that? Because the slope of this kind of graph, the slope of this graph is actually constant. So we can describe that the slope of this graph is constant, which means that at any point in the graph, if you compare any 2 points, then you will have the same slope. And that is the slope of a constant velocity or an object with a constant velocity. Now, how about if the object has changing velocity? You can see here in our moving car, in every second, the rate of change in position is different. As you move through time, or as we observe this object as time passes by, you can see that the interval in the change in position is actually increasing. Here, after 1 second, it's at 2 meters. At 2 seconds, it's now at 8 meters. At 3 seconds, it's 18. So as you can see, the interval increases. Here, it's just 2. Here, it's 6. Here, it's 10, and so on. If you take these as points again in the graph, then you have 0 meters, 0 second, and 0 meter. And then at 1 second, it's at 2 meters. At 2 seconds, it's now at 8. At 3, it's 18. At 4, it's 32 meters. And at 5, it's 50 meters. Now, the graph of the moving object, or the graph of a moving object with a changing velocity, will result into a curved line graph, like that one. Now, what's the importance of slope? Remember, you have the graph of a constant velocity or an object with a constant velocity, which has a straight line. And then the graph of an object with a changing velocity has a curved line. First statement there, if the velocity is constant, then the slope is constant, which is a straight line. If the velocity is changing, then the slope is changing as well, which is the curved line. If the velocity is positive, then the slope is positive, which is moving upwards and to the right. So how does a positive slope look like? If this is our graph, then as stated there, the positive slope is moving upwards and to the right. So that has a positive slope. Of course, the negative one is the opposite. Still moving to the right, but it's moving downwards. This is your negative slope. So how do we use our concept about slope, or how do we use the line in a position versus time graph to describe the motion of the moving object? So let's take a look at these two graphs. We have here, this graph is actually describing, or it helps us in concluding that the object that is observed here is moving slow. It's moving rightward with a constant velocity. So let's take this one by one on how did we arrive at these observations. This graph is a straight line graph, which means the slope is constant. If the slope is constant, remember in the statement that we had earlier, if the slope is constant, then the velocity is constant. Why is the slope constant? Because it has a straight line graph. Next, the slope is positive. How did we identify that the slope is positive? It's moving up to the right. And a positive slope will mean that the object is moving towards the positive direction or the rightward direction. Now, how did we identify if it's slow? As you can see here, in the time that the object was traveling, or in the time that the object was observed, the change in position is just small, which means that, of course, a small change in position in a time interval, it will give you slow, or we can conclude that the object is moving at slow pace. If you compare that in our second diagram here, you have at this change in time, you have a big change in position or a larger change in position, which means that the object is moving fast. So by looking at these graphs, you will know that the steepness of the graph will tell you if the object is moving fast or the object is moving slow. The steeper the slope is, the faster the object is moving. Also, as you can see here, the slope is positive, which means it's moving rightward, and it also has a straight line motion or a straight line graph, which will tell us that it's moving at a constant velocity. Now, another example or another diagram. As you can see here, the slope is now negative because it's moving downward to the right. So this one is slow, leftward, and still has a constant velocity because it has a constant slope, so constant velocity. A negative slope, you have leftward direction. And it's slow because the slope is not that steep. As you can see here, this is only the change in position in this change in time. Now for the other one, you have here a big change in position or a larger change in position in this time interval, which means it's fast. And since it's still in a straight line, then the velocity can be described as constant. Now remember, when the graph is curved, then it has changing velocity. So you can already conclude that these two objects have changing velocity. Both of them are moving leftward because the slope is moving to the right going down. Now, how do you identify if it's fast or if it's moving slow to fast or the change is from fast to slow? If we divide the graph into two parts, which means we divide the time into two equal intervals, you have here the change in position in this first half is just smaller compared to the change in position on the other half of the graph, which means that the movement of the object or the velocity of the object is slow or small, and then it moved faster because the change in position now is greater with the same amount of time. On the other illustration here, and the other graph, if you divide that again, you have the change in time. At the first half, as you can see, it has a greater change in position compared to this one. So from fast, it's moving slow. So that's how you can conclude, or that's how you can describe the motion or the velocities of an object with the use of position and time graphs. Example. So you have here a person is standing at position 1. So this is our position 1. He then walked towards point 2 and continued walking until point 3 and then stops. So based on this graph, let's explain the progress of the man, or let's describe the motion of this man. So it's standing here at point 1 and then it moved through point 2 with a constant velocity. Just these 2 points if we are going to describe the motion of the man between these 2 points. It has a constant velocity because the slope is constant. It's moving rightward because the slope is positive. Now, if we compare that to the motion in the second point going to the third point, as you can see, the slope bent downward, which means this one, the motion here is slower compared to this, or compared to the motion between points 1 and point 2, because point 1 and point 2 is steeper compared to point 3, compared to the motion between point 2 and point 3. So if we are to describe the motion of the man from point 1 to point 2, it's moving at a constant velocity, and then during point 2 to point 3, it slowed down, but still walking at a constant velocity, just slower compared to its motion in point 1 or between point 1 and point 2. Another example, based on the graph, interpret the graph and solve for the velocity of the slope. Solve for the velocity and the slope of the graph. So first, we need to solve for velocity. And if you remember your kinematic equations, you have velocity is equal to the change in position over time, correct? So your change in position here, you have from 0 second, it's now at 30 meters. So the change in position is, of course, the difference there is 30. Over the total time that has elapsed here, you have at 30, it's 15 seconds. Because between 0 and 15, the difference is 15 seconds. So your velocity will be 30 meters divided by 15 seconds. We get 2 meters per second. So that is the velocity. Now, if we solve for the slope of this graph, then remember that slope is equal to your change in y over change in x. So we'll give you y2, oops, it's not a superscript, y2 minus y1 over x2 minus x1. So if we take these 2 points at 0 and 30, at 0 meters and 0 seconds, and 30 meters and 15 seconds, as we look at the graph, so it's a straight line, therefore, at any point in the graph, you will have the same slope. So y2 here is 30 meters there. Then you have 0 meters as your y1, 15 seconds as y2 as x2, and 0 second as x1. The 30 meters minus 0 meters, that's 30 meters. 15 seconds minus 0 seconds, that's 15 seconds. So you will have 30 meters divided by 15 meters. You'll have 2 meters per second as the slope of the object. So if that's the case, or if you look at it, the slope is actually equal to the velocity of the object. We can use the slope of the object or the slope of the graph in a position versus time graph in calculating the velocity of the object. Another example. So using the given graph below, find the velocity of the object in intervals 0 to 3 seconds and 3 seconds to 5 seconds. And then let's interpret the graph. So we have here actually, you have to observe 2 parts. From 0 to 3 seconds and from 3 seconds to 5 seconds. So let's take the first one, from 0 to 3 seconds. How can we find the velocity here? Or how can we solve for the velocity? As mentioned in our earlier slide, that we can use the slope to solve for the velocity of the object. So we have here the velocity of the object will be equal to your change in y, which is your position 1 and position 2, change in position, over your change in time, or your time interval. The velocity will be equal to, your change is of course from 0, or from, you have the final, you have 30 meters, minus, if this is your point 1 and point 2, 0 meters. Now, our time interval here is, we are just observing at 3 seconds, since we are observing 0 seconds to 3 seconds. So you have 3 seconds minus 0 seconds. Then you get 30 meters over 3 seconds. And you will have 10 meters per second. Meaning, during the motion of the object from 0 second to 3 seconds, the object is moving with a constant velocity. Why constant? Because the slope is constant. It's a straight line. It's moving at the rate of 10 meters per second. However, as you can see, the slope changed after 3 seconds. So this is velocity from 0 seconds to 3 seconds. Now, velocity from 3 to 5. If we solve for the velocity from 3 seconds to 5 seconds, again, you have your position 2 minus position 1, and then your time 2 minus time 1. So these are our 2 points now. Your position 2, or this one, is 30 meters. Minus, the position 1 is still 30 meters. As you can see here, they are both 30 meters, even though there was a change in time. So time 2 is 5 seconds, and time 1 is 3 seconds, because we are just comparing them, or we are just solving for the velocity of the object between 3 seconds and 5 seconds. So moving with our operation, you have 0 meters over 2 seconds, because 30 meters minus 30 meters is of course 0. And if that's the case, then your velocity is 0 meters per second. It's still constant because the slope is straight, but however, the velocity is 0, which means that the object is not moving from 3 seconds to 5 seconds. So in a position time graph, if the slope of the line is horizontal, or if the graph is horizontal, then it means that the object is not moving. So you can see here, it has a horizontal slope or horizontal graph. Then we arrive at 0 meters per second. So from 0 second to 3 seconds, then this is 10 meters per second. And then from 3 seconds to 5 seconds, then that's 0 meters per second. And 0 meters per second mean that the object is not moving at all. So that's it for position versus time.